Hi class, my name is Jonathan Casoni, and today I would like to discuss with you the relationship between advertising and sales in the digital environment. This is what I plan to cover for my presentation. Regarding the problem that I wanted to solve, the 3 research questions/hypotheses for this course project included the following. Does a relationship or correlation exist between marketing spent and revenue? Is there a correlation between the number of leads and the amount of revenue? And is there a correlation between the number of leads and the number of orders? To elaborate, businesses continue to evolve in many ways every single day. The market is dynamic. Therefore, as products and services advance in complexity, advertising must follow suit, specifically in the digital environment. To explore this problem further, I chose to analyze the Digital Marketing Metrics and KPIs to measure SQL dataset, which includes the following variables. However, for this project, the variables in question include marketing spent, leads, orders, and revenue. Considering the data analysis, I chose to use JMP because it is an interactive and easy to use statistical software for data analysis and visualization, and it is a subsidiary of SaaS products. As far as the data is concerned, to model a realistic scenario, I used JMP to randomly divide the data into a training dataset and a testing dataset by about 80% and 20% amounts respectively. For the data analysis methods, I created distributions for each of the variables, generated descriptive statistics, and conducted linear regression analysis and k-means cluster analysis. The initial distribution models from the preliminary analysis resulted in 3 significant and extreme outliers that skewed the data, so I removed these records and reran the analyses. The distributions and descriptive statistics illustrated an overview of the data. Linear regression analysis was used to identify whether a statistically significant relationship existed between the variables, and cluster analysis was used to organize the data into groups based on similar characteristics. Starting with the distributions and descriptive statistics, the training and testing split resulted in 255 records for analysis. As I mentioned in my report, since the mean values are greater than the median values, respectively, for all the variables in question, figures 1 through 4 indicate right-skewed distribution, which means that most of the values will appear to the left side of the mean. Additionally, the larger standard deviation indicates that the data is more spread out for each variable. For the linear regression analysis, estimate tables can be found in my report discussing the R-square value, estimates, and p-values, etc. in further detail. For each of these linear regression visuals, I can conclude that based on the respective 0.0001 p-values and lines of best fit, a positively and statistically significant relationship exists between marketing spent and revenue, the number of leads and revenue, and the number of leads and the number of orders. Specifically, Figure 5's estimate value indicates a 1.24 point change in revenue for every 1 point change in marketing spent. Similarly, Figure 6's estimate value indicates a 568.02 point change in revenue for every 1 point change in the number of leads. And last, Figure 7's estimate value indicates a 0.11 point change in the number of orders for every 1 point change in the number of leads. For the k-means cluster analysis, Figure 8 illustrates that most of the data between marketing spent and revenue belongs to cluster 1, specifically between $200,000 for both variables. Furthermore, I can conclude that the typical data point likely lies around a marketing spent value of about $43,000 and an associated revenue value of about $45,000. Figure 9 shows that most of the data points between the number of leads versus revenue ranges from 0 to 400 leads and 0 to roughly a little more than $200,000 in cluster 3. Last, Figure 10 illustrates a similar trend such that most of the data falls between the lower number of leads and lower number of orders. However, the data suggests a potential correlation between a greater number of leads yielding a greater number of orders, respectively. Reflecting on my learning experience while working on this project, first I would highlight the importance of researching the most effective data analysis methods. Second, I would have to reflect on running multiple analyses to obtain the results I wanted, to include removing extreme outliers. Third, I would suggest the importance of finding research questions or data that is interesting because it makes the project more enjoyable and more applicable to our respective futures as data analysts. In conclusion, this is everything I've covered in this presentation. I appreciate your time, and I look forward to this week's discussion. Thank you.